So I wanted to again do another video on the evolution of Geospatial 2.0, and like I share in each of these videos, the world of Geospatial 2.0 is evolving very quickly. Things are changing. I'm learning a lot more. I'm talking to people that are really pointing me in the right direction, and what I've really been working hard on is thinking through the architecture of Geospatial 2.0, which I'm going to share a little bit with you in this conversation. But let me just start by telling you again, for those that are new to these videos, what Geospatial 2.0 represents. It really represents this paradigm shift in how we leverage geospatial data. We're moving away from a static world which requires an analyst to a more automated world which drives us towards getting real-time data and making intelligent decisions and taking action based on situations that change very rapidly. That's a completely new world. It's driven by new data, and it's definitely driven by AI. So let me kind of paint two pictures for you before I dive into the architecture conversation. So the existing world that I call Geospatial 1.5 is driven in this way. Somebody has a question in an organization. Often it's a map-based question. I need a map for X. Think of site selection. Show me the best sites in Salt Lake City for a new Starbucks. I always use that example. So what happens is an analyst, quite often a GIS analyst, logs into a system, finds the right data, and then uses analytical tools to provide insight. So we've got these two pieces, the contextual piece, the relative locations of things, and then the insight piece, which is really the patterns and relationships piece. And often you need tools for that. But that's where everything ends, and that can be a long process to get to that place. It can take days, hours, weeks. What we end up with is a map with dots on it that suggest where you may be wanting to put that new Starbucks. Somebody then has to make a decision about that and take action. That's again a very human-centric approach. So you've got a human who is doing the contextual, insightful piece, delivering it to a human that needs to make a decision and take action. What we're doing in 2.0 is essentially taking those humans out. We're not completely exiting them out of the conversation. We're making sure that there is a human in the loop in the right places, but it doesn't any longer rely on the human. So we're going to automate a lot of the work that's there and inject that human where we need them. That's a critical difference. And when we've got these real-time situations that happen, events that are changing very, very rapidly, and there's ever more of those in the world we live in, that 1.5 model doesn't work. We need to move into the 2.0 world where we can actually have a brain in the room that helps us make those decisions and take those actions. So let me step back for a moment and talk architecturally how, and this is kind of the evolution of 2.0, and I've got my cheat sheet in front of me, so I'll apologize ahead of what I'm about to say, because I may be looking down to remind myself. Very dynamic, changing world of 2.0. So I've spoken about the perception layer. That's really at the very top of the stack, if you like, within the Geospatial 2.0 world. The perception layer, you can think of our own senses there. You know, we hear, we see, we smell. That's our perception. Those are the raw data components that come into our brains, and that's the same in the 2.0 world. So we're talking about all of that raw data, IoT data, satellite data, imagery, SAR, all of the good stuff that we know that sits in the world of geospatial. Static data, which is things that don't move, the building, the river, and real-time data. So these are flows of data that are changing continuously. And again, to use an old example, we have a house, a river, a transmission line. We have a storm that's coming in. So we've got the static stuff and we've got the things that are changing. In the 1.5 world, there's desperate attempts by people to try and update maps based on these changing events. Very intensive, very difficult to do, in fact, impossible to do. 2.0 changes that conversation. So we start at the top, the perception layer. That's the raw data that comes in. So what happens next? That has to be both usable, that data, and available. So two terms that, if you haven't come across these terms, worth looking up, is that data moves into what I call the data fabric layer. That's where we normalize and federate that data. That's a very important next step in the process. So we take that raw data and then we do this normalization and federate that data. So that's the second phase. The third phase, which is highly relevant to, which is actually essential to the 2.0 world, is what I call the translation layer. And that's where we take that data from the data fabric layer and we actually create these knowledge graphs or knowledge maps that I've spoken about. So what does that mean? That means that we add semantics. We enrich that data with semantics, with meaning. That's hugely important. And again, if you think about our brains, we take sensory information in and we start that process of analyzing it. So we have senses that can go, this is a good smell, this is a bad smell, this is, I'm doing a bit of a crude example of it, but there is a second layer where we take our senses and we start that first place of interpretation. That's really what the semantic layer is. It adds meaning to data that might be, again, if you think about a geodatabase for static data, that's geometric data, it's got a location and it's got attributes. It's a building, it was built in 1940, whatever it might be. There's no semantics in that. That's sort of raw information. What this translation layer does essentially is to add meaning to that. So why do we do that? Again, if you think about our brains, we're thinking through our senses, we're thinking through the contextual and the insightful pieces that our senses are bringing to us and combining those pieces. And then we're sort of adding some level of meaning to that. So that's all sort of the groundwork of really what is the core of the Geospatial 2.0 system. And the core of the system is the reasoning engine. And you've heard me talk at length about Verses and their Genius product. Active inference is what that's based on. It isn't based on LLM technology and translators. It's a different approach to leveraging AI, and I think it's going to be a huge approach to as we move forward. I've read things about the performance of Genius in terms of solving problems quickly, and I've also looked at how LLMs work. They're essentially engines which provide prediction. Actually, in essence, they predict the next word. At the heart of an LLM is we're just predicting the next word in a sentence. This active inference is not a translation engine, it's really a reasoning engine, and it's a learning engine as well. And again, I'm using terminology here that's worth you looking up because this is really important to the evolution of technology, which is why we're having this 2.0 conversation. We couldn't have had this 5 years ago because we didn't have all these pieces in place. Now we can have this. So the reasoning engine is critical. I think Genius is probably the premier solution at the minute that would fit into this architecture. So that's the 1, 2, 3, fourth layer. The last layer is the action layer. That's where we actually do something with that intelligence. So if we've got a reasoning engine that's saying, based on what is currently happening, these are the recommendations I've got in terms of decisions. That's kind of where the human in the loop comes in. That's where the human actually is making decisions about which of those recommendations he or she thinks is the right thing to do next. So that's a very important part. That last piece is now we have to take an action, and that's really where agentic AI comes in. That's where we can kind of talk about orchestration, which are the best tools we should use to take some action. Should we be sending out again, I use this example, but an SMS message to an evacuation team to get on the ground quickly, to use these evacuation routes to get the most vulnerable people out very quickly because this storm's an hour away. So there's the action piece. So those are the layers that really make up Geospatial 2.0. And there's a lot more depth to this. I'll share a little bit more in the newsletter. Please sign up if you haven't, because I share more information in there, more detail. And what you've got to remember is we've got loops going on here because the context and insight is changing. What does that mean? It means that it's a storm's coming in, that storm's changing direction, there's more rainfall, there's less rainfall, there's suddenly hail in it, the winds are suddenly changed from a certain number of knots to a much higher number of knots. So the changing situation is absolutely critical. So what does that mean to the system? The system has to be cycling through, understanding what's changing. If there was a recommendation from the reasoning engine based on 10 minutes ago, that might have changed as the storm changes. as an example. So we have to be continually feeding the system this data, and that's really at the top 3 layers where that happens. So it's a very dynamic system, not a static system. So last piece is, where do LLMs have a place in this conversation? LLMs are really important in this architecture I'm talking about. They're really the access point to this. So think about when you use ChatGPT. ChatGPT will come back through prompts, ask you questions for you to then it to understand what you're talking about, maybe give you recommendations back on a particular question or something you're thinking about. That's the same thing that would be used in this system, except what that LLM is doing is having a user ask a question. For example, what should we do now? We know there's a storm coming in. We're very worried about the most vulnerable population. Help us make some decisions there. An LLM can't think through that stuff. An LLM almost sort of parrots things back, and it's a sort of a predictive model, but it can help understand intent. What is your intent when you ask this question? What happens from the LLM is it spits that information directly at the reasoning engine. So the reasoning engine is then the piece that does the thinking and all of the rest of the process. So the LLM is that access point to the whole system. And the beauty of LLMs is anybody can ask these questions. We don't need to be an expert at anything to do this. We simply interact with the system. But what we've done is we've added a brain behind that LLM. So anyway, a long talk, a really important talk. The architecture I'm talking about is becoming reasonably solidified. The more that I talk to people, the more I know the tools that fit into the equation here. Potentially a modification to this, but I think we're pretty solid in what that architecture looks like. There's one other piece that I'll add, but this will be in the newsletter, about why the reasoning engine and using active inference is such a huge piece of this puzzle. And scalability is the question, is what I'll be talking about there. So again, I know, cheap plug again, but please sign up for the newsletter and you'll learn a bit more about this stuff from within the newsletter. So again, I love your comments. I love any feedback you've got. I love new information. So share with me anything that comes to mind as you listen to this. And I'll do another one of these very soon. Thanks for watching.